Welcome to the deep dive. Just take a moment and think about how deeply artificial intelligence has, well, woven itself into your daily existence. It's recommending what you should binge watch next, sure, that's obvious. But it's also influencing these major life moments. Things like whether your loan application gets approved, or even contributing to a medical diagnosis. AI isn't some far off future thing anymore. It's here, right now, and often subtly shaping our world in ways we barely even recognize. For years, the rallying cry, especially out of Silicon Valley, was always move fast and break things.
Right.
It was all about speed, innovation, getting products out the door, figure out the problems later. But in the world of AI, that whole ethos is undergoing this profound and really necessary transformation. We're seeing a critical shift towards a much more responsible, more considered approach to building this technology. So, what are we diving into today? We're taking a deep plunge into a practical guide called Building Ethical AI Systems. Our mission here is simple: extract the most crucial, actionable insights from this material for you. We want to give you a shortcut, basically, to understanding why responsible AI development isn't just optional anymore. It's become a non negotiable imperative. And crucially, how it's actually being built, brick by ethical brick. This deep dive is really custom tailored for you, the curious learner, designed to give you clarity and depth, but without drowning you in jargon.
And that shift you mentioned, it's far from just some academic exercise or, a corporate buzzword. It's absolutely vital. Why? Because of AI's expanding footprint, especially in what we call high-stakes decisions. We're talking about core sectors like healthcare. An AI error in diagnosis, that could literally be life or death. Or finance, an algorithm determining who gets credit, or housing, or even just basic banking services. Then there's criminal justice, AI potentially influencing sentencing or parole decisions. And of course, employment, who gets hired, who gets promoted. This kind of pervasive societal penetration means the potential for AI systems to cause really significant widespread harm is incredibly real. Yeah, our sources highlight some pretty vivid examples. Think about loan applications that turn out to be inherently biased, maybe disproportionately denying credit to certain racial groups or socioeconomic groups, or medical diagnostic tools that might miss critical conditions just because the training data didn't adequately represent, say, diverse patient populations. Or even hiring algorithms that inadvertently just perpetuate existing inequalities, screening out perfectly qualified candidates based on totally irrelevant or even discriminatory proxies hidden in the data. These aren't just hypothetical what-ifs anymore, they're documented instances. They highlight the severe, tangible consequences of unchecked AI development. So building ethical AI, it's not just a moral nicety. It has undeniably become a legal, a commercial, and a societal necessity. Full stop. And this necessity is being powerfully underscored by the accelerating pace of global regulations. Think about the landmark EU AI Acts and also the very severe financial penalties and, frankly, the reputational damage companies face when their AI systems fail ethically. The stakes honestly couldn't be higher for individuals, for organizations, and really for society as a whole.
That's a really powerful framing. It sounds like we're definitely moving past a speculative, what if AI goes wrong phase into a very practical, okay, how do we ensure AI does right era? And when we talk about building that trust, it's not some abstract concept that just magically appears, right? Trust in AI, it has to be deliberately engineered, it has to be woven into the very fabric of the system from the start. And then rigorously maintained throughout its entire life cycle. It's an ongoing active process. And this is where our source introduces something really compelling: the trustworthy AI framework. This isn't just another set of guidelines, it's presented as this comprehensive tripartite framework, meaning it rests on three essential interconnected pillars. All three must be satisfied for an AI system to be considered truly reliable and, well, worthy of our confidence. And those pillars are lawful, ethical, and robust.
Indeed. And breaking down each of these pillars is really crucial because they each address a distinct yet equally important aspect of what makes an AI system trustworthy. They are absolutely foundational elements, not just optional add-ons you can sprinkle on later. So first up, we have lawful AI. This is truly the absolute baseline, the non-negotiable floor for any AI system you deploy. At its core, it just means the system has to operate in full, unwavering compliance with all applicable laws and regulations. Think of it as the foundational layer of accountability. Our sources point to a whole range of legal frameworks that AI systems need to respect. This includes comprehensive data protection laws, like the GDPR in Europe, General Data Protection Regulation, setting really stringent rules on handling personal data. And then you've got things like the CCPA, the California Consumer Privacy Act in the U.S., giving consumers significant rights over their personal info. But it goes beyond just data privacy. We're also talking about anti-discrimination laws, ensuring AI doesn't create or perpetuate unfair biases.
And then there are various sector-specific regulations, finance, healthcare, transportation. They all have their own rules AI needs to follow. But it's really crucial to understand the significance of new overarching legislation, like that landmark EU AI Act you mentioned. Once that's really implemented, it's not just another law on the pile. It establishes legal adherence as a baseline requirement for even accessing and operating within the EU market. Put simply, if your AI system doesn't comply, you literally cannot deploy it or sell it there. That's a very high bar, and it makes legal compliance a fundamental strategic consideration now, not just some tick box exercise for the lawyers.
Okay, so lawful is the absolute floor. Got it. What's next?
Next, we ascend, you could say, to ethical AI. This pillar goes beyond just the letter of the law. It demands that AI systems actively align with established ethical principles and broader societal values. While laws provide that necessary minimum standard, ethics pushes us to aspire higher. It involves a deep commitment to fundamental ideals, things like ensuring fairness, actively preventing harm, and respecting human autonomy and dignity. Imagine a scenario, right? A law might not explicitly forbid a certain AI behavior, but that behavior could still lead to, say, detrimental social outcomes, or maybe infringe upon basic human values. That's where ethical considerations become the developer's compass. They guide developers in navigating those tricky gray areas that laws might not cover yet, ensuring the AI genuinely serves the common good and contributes positively to society rather than just, finding loopholes or skirting legal boundaries. It's about building AI that is not only legally permissible but also morally sound and socially beneficial.
Okay, so beyond legal compliance to actually doing good, or at least aligning with our values. And the third pillar.
And finally, the third pillar is robust AI. This one is really all about the technical integrity, the reliability, and the security of the system itself. Think of it as the engineering bedrock. An AI system, to be truly trustworthy, must perform as intended, reliably and accurately, even when it's faced with unexpected inputs or, say, changing environments it wasn't explicitly trained for. And this isn't just about making sure the AI works most of the time. It's critically about its resilience. It needs to be resilient against both accidental failures, like a bug in the code, or unexpected data patterns throwing it off, and also against malicious adversarial attacks. These are deliberate, often very subtle attempts by bad actors to compromise the AI's integrity, maybe trick it into making incorrect decisions or exploit its vulnerabilities for, nefarious purposes. Building robust AI means designing systems that can withstand these challenges, ensuring their performance is stable and dependable under a wide array of conditions, and crucially, that they cannot be easily manipulated or broken.
So, hearing all this, if you're an AI developer or a data scientist or maybe anyone involved in creating or deploying these systems, even procuring them, you might be thinking, wow, my job just got a whole lot more complex.
Ah.
And you'd be absolutely right. Our source articulates this shift beautifully. It says the modern AI developer's role has expanded far beyond just being, a coder or a model builder. They are, in essence, becoming ethical architects. And that isn't hyperbole. It's a profound recognition of their unique position in this process. Every design choice they make, every line of code they write, every algorithmic implementation, these things can have deep and lasting societal consequences.
That's exactly it. Think about it. The specific data they choose to train a model on, the features they engineer from that data, even the performance metrics they choose to optimize for, none of these are neutral decisions. These key choices can either inadvertently perpetuate and amplify existing societal inequalities, the ones already embedded in our history and data, or conversely, they can actively help to create a more fair and just world. That's an incredible amount of power, right? And with that comes a commensurate amount of responsibility.
So, what does this all mean for you, our listener? Whether you're that developer or maybe a product manager, a business leader, even a policymaker trying to grapple with this, it means understanding this foundational responsibility, recognizing that building AI is no longer solely a technical challenge, it's about shaping society. And being equipped to navigate this complex, critical area is paramount. We need to ensure the AI we build is not only powerful and innovative, but also principled and genuinely beneficial. Okay, so to really build on that ethical pillar we just discussed, our source goes even deeper. It lays out what it calls the foundational pillars of trustworthy AI.
These are core ethical principles that seem to have achieved broad global consensus. What's really fascinating is how, even with slightly different names or emphasis across various frameworks and organizations, a unified set of 5 core principles consistently emerges. They draw significant inspiration, interestingly, from the field of bioethics, which has grappled with similar questions of impact and responsibility in medicine for decades. And here's a crucial point they make. This isn't just a checklist. You don't just tick off justice and move on. These principles are deeply interconnected. They often exist in this state of productive tension with each other, meaning you'll frequently find yourself needing to make careful, context-aware trade-offs between them. So let's unpack these 5. We have justice, also known as fairness, then explicability, which covers transparency and explainability, then autonomy, focusing on human oversight, non-maleficence, which includes safety and privacy, and finally, beneficence, aiming for overall well-being. Let's dive into each one. Where should we start?
Let's start with the principle of justice. Often you'll hear it called fairness and non-discrimination. They're largely interchangeable here. The core mandate is crystal clear. AI systems absolutely must be designed to be inclusive, accessible to everyone, and critically, they must not involve or result in unfair discrimination against any group or individual. This principle is paramount, especially in those high-stakes contexts we talked about: employment screening, credit scoring, housing applications, even criminal justice systems. In these areas, biased algorithmic outcomes can inflict significant tangible harm on people's lives. And troublingly, they can even reinforce systemic inequalities that are already present in society.
Right, amplifying existing problems, so understanding bias is key here.
Absolutely. And understanding bias is deeply multifaceted. It goes way beyond just surface-level issues. Our source meticulously identifies several primary sources where this algorithmic bias can creep in. First, there's historical bias. This happens when an AI model is trained on historical data that just inherently reflects past and present societal prejudices and inequities. So, for example, if a hiring model is trained on decades of data from a male-dominated industry, it might inadvertently learn to unfairly penalize female candidates. Not because of their qualifications, but simply because the historical patterns it learned were skewed from the start.
Okay, so the past poisons the present, essentially.
Exactly. Then we encounter representation bias. This is a critical issue. It arises when the training data used to build the model doesn't accurately reflect the diversity of the population it will actually be used on. So if a particular demographic group is underrepresented in the training set, maybe certain racial groups in a medical imaging data set, the model will predictably perform less accurately or even fail completely when applied to individuals from those underrepresented groups.
The data doesn't match the real world it's supposed to operate in.
Precisely. We also have measurement bias. This stems from flaws or inconsistencies in the data collection process itself. Imagine a facial recognition system trained mainly using images from cameras that are just technically better at capturing lighter skin tones, maybe due to lighting or sensor calibration. This introduces a measurement bias that will inevitably lead to higher error rates for individuals with darker skin tones.
So the tools used to gather data can themselves be biased?
Correct. And finally, there's algorithmic bias. This isn't about the data's origin, but rather how the algorithm itself learns and optimizes. In its relentless quest for, say, prediction accuracy, an algorithm might exploit unintended correlations or proxies for sensitive attributes like race or gender, even if those explicit attributes were intentionally removed from the data. For example, it might latch onto things like postal codes or maybe certain linguistic patterns as a stand-in for demographic information, leading to biased outcomes anyway.
Wow, okay, so bias can come from history, representation, measurement, or the algorithm itself. That's a lot of places for things to go wrong.
It is. And a critical challenge when you try to apply this concept of fairness in AI is that, well, it has no single universally accepted mathematical definition. It's incredibly context dependent. What's considered fair in one situation might not be in another. The source outlines several common mathematical criteria that developers use to try and operationalize fairness, each with its own implications and trade-offs. One is demographic parity. This is pretty straightforward. It means the AI's predictions should be independent of a given sensitive attribute. So for loan applications, the percentage of applicants approved should ideally be the same for all racial groups, regardless of other factors beyond maybe core financial metrics.
So equal outcomes across groups, basically.
Roughly, yes, in terms of positive prediction rates. Then there's equalized odds, which is a bit more nuanced. It demands that the error rates specifically, both false positives and false negatives, are equal across different groups. So a medical diagnostic tool aiming for this would need to misdiagnose healthy patients as sick, false positives, and miss actual diseases, false negatives, at the same rate for both men and women or across different ethnic groups.
Okay, so the mistakes are distributed equally.
Precisely.
Yeah.
And then there's equal opportunity. This is a slight relaxation of equalized odds. It simply requires that the true positive rate, the rate at which the AI correctly identifies positive outcomes, is equal across groups. In a hiring context, this would mean that qualified candidates should be recommended by the AI at the same rate across, say, different gender groups or different racial backgrounds. It focuses on getting the yes answers right equally.
So, different ways to find fair. Choosing the right one must be tricky.
Extremely tricky. And it depends heavily on the specific application and its potential societal impact. There's often no single right answer, just different trade-offs.
Okay, that's justice fairness. What's the next principle?
The next vital principle is explicability. This covers two closely related but distinct concepts: transparency and explainability. The core mandate here is fundamental. All stakeholders, developers, deployers, end users, regulators, everyone must be able to understand how an AI system functions, the rationale behind its specific decisions, and, crucially, its inherent strengths and limitations. This isn't just a nice-to-have feature. Explicability is a crucial enabler of nearly every other ethical principle we're talking about. It's essential for identifying bias, for individuals to contest unfair outcomes, and for assigning responsibility when things inevitably go wrong.
So we need to be able to look under the hood, essentially. What's the difference between transparency and explainability?
Good question. They're often used interchangeably, but have distinct meanings. Transparency refers more to the clarity of the overall process of AI development and deployment. It's about providing comprehensive, understandable information about the system's basic design, the characteristics of the data it was trained on, its intended purpose and scope, and the governance structures overseeing its use. Transparency basically answers the questions: what went into building this system and how is it governed and managed?
Okay, transparency is about the big picture, the process.
Exactly. Whereas explainability, or XAI, explainable AI, is much more focused. It's the ability to understand a specific outcome or a particular decision made by the model for a given input. This directly tackles the famous black box problem, especially with complex models like deep learning, where tracing the internal logic is really difficult. Explainability answers the direct question: why did the model make this particular decision for this specific case?
Like why my loan was denied, specifically.
Precisely. Why this loan applicant was denied, or why this medical image led to that particular diagnosis. It's about individual decisions. The benefits of prioritizing explicability are substantial. First, it fundamentally builds trust. Second, it vastly helps with debugging and auditing, finding errors or biases. Third, it's increasingly required by regulations like the EU AI Act. And maybe most importantly, it empowers individuals to actually contest decisions that affect them, giving them agency.
Right, you can't argue with a black box. Okay, that makes sense. Principle number 3.
The third principle is autonomy, which emphasizes human agency and oversight. The core mandate here is foundational. AI systems should always be designed to augment and empower human intelligence, not to replace or diminish human responsibility. Ultimately, the final authority, the final control, and the clear accountability for decisions made with the assistance of AI must, without exception, remain with human beings. This isn't just philosophical, it's a practical safeguard.
So humans always need to be in charge, basically. How does that work in practice?
Well, it leads directly to concepts like human in the loop versus human on the loop. A human-in-the-loop approach means a person must explicitly approve every high-stakes decision the AI recommends, like a co-pilot who has the final say before executing an action. A human-on-the-loop model, in contrast, involves a person monitoring the overall performance of the AI system and intervening only when necessary, maybe when performance degrades or an anomaly is detected. The level of oversight needed has to be carefully calibrated. It should be proportionate to the potential for harm the AI system could cause. For decisions affecting fundamental rights, someone's freedom, access to critical services, direct human involvement, and clear accountability are absolutely non-negotiable. And beyond just oversight, this principle stresses that AI should never be used to deceive, coerce, or unfairly manipulate individuals. It's about respecting human dignity and free will. To make this real, users must always be clearly and proactively informed when they are interacting with an AI system, so they know it's a machine, not a person, and can adjust their expectations.
No fooling people into thinking they're talking to a human if they're not. Got it. Okay, fourth principle.
Fourth, we address the principle of non-maleficence. This broadly covers privacy, security, and safety. It's rooted in that ancient medical precept. First, do no harm. It's a foundational ethical duty requiring AI systems to be inherently safe, rigorously secure, and deeply respectful of individual privacy throughout their entire life cycle, from conception all the way to retirement.
Okay, do no harm. How does that break down for AI?
It breaks down into three key interconnected areas. First, privacy and data protection. Given that AI systems are often voracious consumers of data, strict adherence to legal frameworks like GDPR isn't just a requirement, it's an ethical imperative. Best practices here include data minimization, only collecting the absolute minimum data needed for the AI to function effectively. This reduces the risk if there's a breach. It also relies heavily on privacy-enhancing technologies, PETs, like advanced anonymization to strip identifiable info, and robust encryption for data both in transit and at rest.
Minimize the data, protect what you have. Makes sense.
Second, robustness and security. This builds on our earlier discussion of their robust AI pillar. Systems must be resilient not only to unintentional failures, bugs, weird data, but also to intentional, malicious attacks. This includes protection against those adversarial attacks where subtle input changes cause catastrophic errors. It also means securing the model itself from attempts to extract the data it was trained on or steal the intellectual property.
So making it hard to break or misuse.
Exactly. And third, safety. At its most fundamental, this means AI systems must operate reliably and predictably. And crucially, they must not pose unreasonable risks to the physical safety or mental integrity of human beings. Think about AI controlling autonomous vehicles or critical medical devices. Ensuring safety requires incredibly rigorous testing and validation, not just in labs, but in realistic simulations, to guarantee safe behavior under all sorts of conditions.
Okay, privacy, security, safety. That covers non-maleficence. What's the final principle?
Finally, we come to the principle of beneficence. This focuses on human, social, and environmental well-being. Its core mandate is quite expansive and aspirational. It states that AI should fundamentally be a tool for human progress. Its development and deployment should consistently serve humanity and the common good, actively aiming to increase human flourishing, and critically addressing some of humanity's biggest challenges.
So AI should actually make the world better.
That's the goal. This principle encourages a paradigm shift, pushing developers and organizations to look beyond just purely financial metrics or simple efficiency gains. It calls for a deliberate focus on creating genuinely positive outcomes for individuals, for society, and for the environment. This means actively trying to align AI development with global initiatives, like the UN's Sustainable Development Goals, tackling climate change, poverty, improving education, health, etc. Beneficence necessitates a deliberate, documented assessment to ensure that the likely overall benefits of an AI system substantially outweigh its foreseeable risks and potential harms. It's about ensuring AI is a net positive force, thoughtfully designed to contribute to a better world.
Wow, okay. Justice, explicability, autonomy, non-maleficence, beneficence. That's quite a comprehensive set of principles. They all sound incredibly valuable on their own. But what our source really drives home, you mentioned this earlier, is that these aren't just a simple checklist. They exist in this really complex dynamic relationship. They often create inherent tensions, forcing developers and organizations to make some genuinely difficult trade-offs. It's about navigating these conflicts with wisdom, foresight, and, crucially, a lot of transparency.
Precisely. It's rarely straightforward.
Yeah.
Let me give you a few concrete examples of this complexity, this tension. First, consider the tension between justice or fairness and non-maleficence, particularly privacy. To accurately measure and mitigate bias against specific demographic groups, say, to ensure a loan system isn't unfairly disadvantaging one community, a model might actually need access to sensitive attributes like race, gender, or age during its auditing phase. You need the data to see the bias.
Right.
However, collecting and using this sensitive data runs directly counter to the principle of privacy and best practices like data minimization.
Ah, okay. So to fix unfairness, you might need data that risks privacy. How do you resolve that?
Well, the source suggests solutions like using the sensitive data only for fairness audits, not for the actual model training itself, or employing advanced privacy-enhancing technologies like differential privacy that allow for analysis without revealing individual identities. It's a balancing act.
Okay, that makes sense. What's another example?
Then there's the conflict between explicability, transparency, and non-maleficence, specifically security and intellectual property. Achieving maximum transparency, maybe by fully open sourcing a model's complete architecture and training data, would make it incredibly understandable and auditable.
Sure, totally open.
But that level of openness could also make the system dangerously vulnerable to sophisticated adversarial attacks, compromising its security. And not insignificantly, it would expose valuable intellectual property that a company has invested heavily in developing.
So being totally open makes you easy to understand, but also easy to attack or copy.
Exactly. You're constantly balancing the need for openness with the need for protection.
And you mentioned accountability earlier.
Yes, and here's another big one, a really foundational tension. Accountability versus explicability. It's incredibly difficult, maybe even impossible, to hold a person or an organization truly accountable for a harmful outcome if the decision-making process that led to it is just an opaque black box that nobody can interpret or understand.
If you can't explain why the AI did something wrong.
How can you assign responsibility? How can you investigate errors effectively? How can you provide meaningful redress? So, achieving a sufficient degree of explainability isn't just nice, it's often a necessary precondition for establishing any meaningful accountability framework.
Okay, wow. What these examples really reveal is that ethical AI development isn't just a purely technical problem with a single right answer you can code. It's this continuous socio-technical process. It involves constant negotiation, balancing competing values.
That's exactly right. The developer's task is elevated beyond just writing code. They have to consciously identify these trade-offs, thoroughly evaluate their implications, transparently document the choices they make, and clearly communicate the rationale behind those choices. It really transforms the work from pure engineering into a form of reasoned, ethical judgment that requires deep contextual understanding.
So we've laid out the philosophy, the core ethical principles, but what does this all mean when we move from these perhaps somewhat abstract concepts to practical, real-world implementation? How do we make it happen? It means building a robust governance and accountability ecosystem. You can think of it as the critical bridge that connects that ethical intent with actual, responsible outcomes in the real world. Without this structure, even the best intentions for ethical AI can, unfortunately, just fall flat.
Precisely. And the bedrock of effective AI governance starts with establishing robust organizational structures. A widely recognized best practice here is setting up a cross-functional AI ethics committee. And this isn't just a committee of IT folks or legal eagles. To be truly effective, it must be cross-functional. It needs diverse perspectives from across the organization. So yes, IT and cybersecurity, legal and compliance, but also people from core business units, HR, marketing, product development, customer service, and crucially, some leading organizations even bring in external experts, maybe ethicists or sociologists, to help identify potential blind spots internal teams might miss.
So diverse voices around the table. But what does this committee actually do?
Good question. It can't just be a discussion group. It needs a clear mandate and charter to function as a genuine working governance body. Its responsibilities typically include several critical functions: developing, approving, and periodically reviewing the organization's overarching AI strategy and ethics policy, rigorously evaluating and approving proposed AI use cases before development really kicks off, assessing risks, checking alignment with guidelines, providing ongoing ethical oversight throughout the AI lifecycle, and diligently monitoring the performance, risk posture, and compliance of AI systems once they're deployed.
Okay, so they set the rules, vet the projects, and keep an eye on things. What about when something goes wrong?
That leads to accountability structures. A fundamental question must be answered decisively. When something goes wrong, who exactly is responsible? This requires establishing clear hierarchies of responsibility for each AI system. Our sources highlight models like the one from the Information Technology Industry Council, ITI. It offers a useful framework. It delineates distinct, though often shared, responsibilities among developers who build the core AI, deployers who use the AI for a specific purpose, and integrators who might combine and customize AI systems. This clarity helps prevent that diffusion of responsibility that can easily happen in complex AI projects.
Okay, so clear roles. Beyond the committee and accountability, what else does governance involve?
Beyond organizational structures, systematic risk management is truly the engine of effective AI governance. Organizations need a structured, repeatable process for identifying, assessing, and mitigating risks throughout the entire AI lifecycle.
A repeatable process, like a standard framework.
Exactly. A leading example here is the NIST AI Risk Management Framework, AIRMF. It was developed by the U.S. National Institute of Standards and Technology. While it's technically voluntary, it's become highly influential globally. It's not a rigid checklist, but rather a flexible, process-oriented guide designed to be adaptable to any organization, any sector. It operates on 4 interconnected functions. First, govern. This is about establishing and cultivating a risk-aware culture within the organization, integrating AI risk management into broader strategy, setting the tone from the top. Second, map. Here, the focus is on identifying the context of the AI system and its potential risks, understanding its capabilities, limitations, and potential positive and negative impacts on everyone involved. Third, measure. This involves analyzing, assessing, and tracking identified risks. This can use quantitative methods like statistical bias analysis and also qualitative methods like expert judgment or user feedback. And fourth, manage. Once risks are measured and prioritized, this function is about allocating resources to actually treat those risks, developing mitigation strategies, implementing them, and making informed decisions about risk acceptance. Practically adopting this means systematically inventorying AI systems, rigorously assessing their risks, and embedding these processes into daily workflows.
Govern, map, measure, manage.
Okay. And are there specific tools within that framework?
Yes, key tools within this risk management paradigm are impact assessments. These are crucial for evaluating potential consequences before deployment. An AI impact assessment, AIIA, is a systematic process to identify, analyze, and minimize potential negative impacts an AI system could have on people, society, the environment. Ideally, this is done very early in the design phase before big resources are committed, and it's vital. It involves a diverse, multidisciplinary team to catch blind spots. A more specific type is the Fundamental Rights Impact Assessment, FRIA. This is actually mandated by the EU AI Act for all high-risk AI systems. It specifically zeroes in on evaluating the potential impact on fundamental human rights, ensuring those core liberties are protected.
Right, connecting back to the EU AI Act, that seems like a really big piece of this puzzle. It absolutely is. And it brings us to this rapidly evolving area, navigating the regulatory landscape. We're seeing a clear shift from an era where AI ethics was mostly voluntary guidelines to one increasingly defined by legally binding regulation. Developers, organizations, they must be fluent in these frameworks now.
Tell us more about the EU AI Act. It sounds like a game changer.
It really is. It's widely seen as the world's first truly comprehensive horizontal legal framework specifically for AI, and it's already setting a global benchmark. It uses a risk-based approach, meaning the obligations depend on the AI's potential for harm. At the top are unacceptable risk practices. These are AI applications deemed a clear threat to fundamental rights, so they're banned outright. Examples include things like social scoring by governments or real-time remote biometric identification in public spaces like widespread facial recognition surveillance, though there are narrow exceptions for law enforcement under strict conditions. Also banned are AI systems using manipulative or deceptive techniques to cause harm.
Okay, so some things are just off limits entirely.
Correct. Next are high-risk systems. These are AI systems used in critical sectors where failure could cause significant harm: health, safety, fundamental rights. Think AI in medical devices, critical infrastructure operation, recruitment software, educational assessments, law enforcement tools. These systems face strict obligations. Before hitting the market, they need a conformity assessment and must meet rigorous requirements for risk management, data quality, transparency, documentation, human oversight, accuracy, robustness, and cybersecurity. It's a long list.
A very high bar for those critical applications.
Indeed. Then we have limited risk systems. For AI like chatbots or maybe emotion recognition systems, the main obligation is transparency. Users must be clearly told they're interacting with an AI so they can make informed decisions. And finally, the Act introduces specific transparency requirements for generative AI models, like the large foundation models we hear so much about. This includes disclosing that content is AI-generated, trying to prevent illegal content generation, and publishing detailed summaries of copyrighted data used for training. This reflects the unique societal impact of these powerful new AI types.
And is this just happening in the EU?
While the EU AI Act is pioneering, it's important to note that other global frameworks are rapidly emerging. It signals a broad international consensus. For instance, Australia's AI ethics principles, initially voluntary, are seeing a push towards mandatory guardrails for high-risk AI. This global trend shows responsible AI is becoming the standard, not the exception.
It really feels like the Wild West days are ending.
They absolutely are. And for a practical example of how a company puts this into practice, consider SAP's approach to internal AI policies. SAP, the big enterprise software company, formally adopted guiding principles based on UNESCO's comprehensive AI ethics recommendations. They then translated these broad principles into a binding internal document, the SAP Global AI Ethics Policy. But policy isn't enough, right? So they created the SAP AI Ethics Handbook, a practical guide mapping policy requirements directly to specific stages of SAP's AI development lifecycle. Key mechanisms include a mandatory AI use case impact assessment for every new AI project, and clearly defined red lines, strictly prohibited uses, like mass surveillance, discrimination, or manipulating public opinion. These act as clear boundaries.
That's a great example of operationalizing it. So what's the big takeaway on governance?
The overall takeaway is critical. AI governance cannot be a reactive, one-time audit. It's not an afterthought. It must be a proactive, continuous, and well-resourced process, embedded deeply throughout the entire AI lifecycle, from concept to retirement. Failure isn't just an ethical lapse anymore. It poses significant compliance and financial risks. Under the EU AI Act alone, potential fines for non-compliance can reach up to 7% of a company's global annual turnover. For big tech, that's potentially billions of dollars. This really underscores that responsible AI isn't just about doing the right thing. It's about safeguarding the very future of an organization in the age of AI.
Okay, so after all that on the why and the overarching structure, you might still be wondering, okay, what does this mean for me practically if I'm trying to build these systems or even just understand them better? We've hit the principles, the frameworks. Now let's talk about the practical how. Our source provides a really valuable resource here. It's an EU AI Act, a developer's checklist for high-risk systems. Now, while it's specifically tailored for EU compliance, its practical steps and detailed documentation requirements are incredibly relevant for anyone building these systems anywhere. It covers everything from risk management and data governance to technical documentation, record keeping, transparency protocols, human oversight mechanisms, accuracy, robustness, cybersecurity, the whole 9 yards. You really need to know what these requirements look like because they are rapidly becoming the de facto global standards for responsible AI development. It offers a tangible roadmap for integrating these ethical considerations into the actual work. And that roadmap leads us naturally into the core idea that truly embedding ethics into AI isn't just about good intentions. It requires a structured, deliberate approach, integrated into every single phase of the project lifecycle. It's not about bolting on some ethical checks at the very end. It's a continuous, iterative process, starting right from the initial spark of an idea and continuing throughout the system's entire existence. Let's walk through those stages.
Absolutely. The first critical stage is stage 1, envisioning and design. This is the conception phase. Here, the very first step is clarity. Define the project's purpose and scope. Articulate the specific problem the AI aims to solve, the benefits it should deliver, and crucially, document what's explicitly in scope, and just as importantly, what's out of scope. This proactive boundary setting prevents mission creep and unintended uses later. Equally vital here is stakeholder identification and engagement. You need to identify all affected stakeholders, not just end users, but broader communities, marginalized groups, anyone who might experience downstream consequences. Engaging them early and continuously is paramount. It gathers diverse perspectives, uncovers potential harms a homogeneous team might miss, and builds trust from the get-go. Finally, this stage involves consequence scanning and rigorous risk assessment. Proactively brainstorming potential negative impacts, malicious uses, unintended consequences before writing code. Using tools like an AI impact assessment, AIIA, helps analyze risks and ensure benefits truly outweigh harms. It's structured foresight.
Look before you leave, basically. Okay, stage 1, vision and design. What's stage 2?
Moving right along, we hit stage 2, data sourcing and preparation. Since AI models are fundamentally shaped by the data they eat, this is an absolutely critical ethical juncture. Our source highlights the datasheets for datasets framework. Think of it like a nutrition label for data. It's presented as an indispensable tool for transparency and accountability. Developers should create or demand a datasheet for every dataset, documenting its motivation, composition, collection process, pre-processing steps, recommended uses, limitations, everything. This forces critical reflection on the data's origin, its limits, its suitability. Then comes auditing for bias and representativeness. Data is a primary source of AI bias, so it needs rigorous auditing. Analyze its distribution for underrepresented groups, check for imbalances in the target variable, evaluate original sources and collection methods for inherent biases. Ensure high data quality errors, inconsistencies, missing values can skew training. And finally, data governance and privacy are paramount. Strict adherence to laws like GDPR, respecting user consent, practicing data minimization, only collect what's needed, using data anonymization or pseudonymization wherever possible.
Data sheets for data sets. I like that analogy. Okay, so we've got clean, fair, well-documented data. Now what?
Now we move into stage 3, model development and training. This is where ethical considerations translate directly into technical choices made by the developers. A key focus is integrating fairness into modeling. This involves using in-processing bias mitigation techniques. Developers actually incorporate fairness metrics directly into the model's objective function during training. So instead of optimizing only for raw prediction accuracy, the model is now also penalized if it generates unfair outcomes across different groups. It's forced to actively reduce disparities as it learns. Algorithm selection itself has ethical implications. For high-stakes scenarios where explainability is crucial, maybe medical diagnostics or justice, it might be far more responsible to choose a simpler, more inherently interpretable model, like linear regression decision tree, even if it means a slight trade-off in raw performance compared to a complex black box neural network.
So sometimes simpler is better, ethically speaking.
It can be. Developers should also employ bias-aware techniques and apply fairness constraints during training, actively guiding the model towards predefined fairness criteria, like ensuring equal error rates across demographic groups. It's about baking fairness in, not trying to fix it later.
Baked-in fairness. Got it. Stage 4, evaluation.
Exactly. Stage 4, evaluation and validation. And crucially, evaluation here must go way beyond just measuring overall accuracy. As our source rightly points out, a model boasting 99% overall accuracy can still be 100% unfair to a specific subgroup. This demands a multifaceted, rigorous approach. Fairness audits are essential, systematically measuring performance across different demographic subgroups, calculating various fairness metrics using specialized tools like AI Fairness 360. Robustness and security testing are also vital. Testing resilience against noisy, out-of-distribution, or even adversarial inputs. Does it hold up under stress? Red teaming, borrowed from cybersecurity, involves proactively attacking the model, trying to discover its vulnerabilities, failure modes, potential for misuse by intentionally trying to break or mislead it.
Trying to break your own system to make it stronger.
Precisely. And finally, evaluation in real-world contexts is critical. Don't just test on clean lab data. Test in environments simulating the messy, complex conditions of the real world where it will actually operate.
Okay. Rigorous testing on multiple fronts, then comes deployment.
Yes, stage 5, deployment and documentation. The Model Cards framework is a crucial piece of documentation here. It acts like that nutrition label again, but for the trained AI model itself. It provides a concise, structured summary. Performance across demographics, known limitations, intended uses. Essential for a responsible handoff from development to operations. Instead of a risky big bang deployment rolling out to everyone at once, staged rollouts are much safer. Techniques like canary release or A/B testing deploy the model to a small subset of users first. This allows for close monitoring and quick rollback if issues arise. Lastly, clear user communication is core. Users must be clearly informed when interacting with an AI, provide clear, understandable info about its capabilities, limitations, and how to report problems or seek redress. Transparency is key.
Model cards, staged rollouts, clear communication. Makes sense, but it doesn't end there, right?
Absolutely not. The life cycle is continuous. Stage 6, monitoring and iteration is vital. AI is not a set-it-and-forget-it technology. It needs constant oversight and maintenance. Continuous monitoring is essential for detecting several critical issues. Performance degradation: does accuracy erode over time? Model drift: do the statistical properties of real-world data change from the training data, making the model outdated? And the emergence of new or undetected biases that might only surface in real-world use. Organizations must establish clear, accessible feedback and grievance mechanisms, channels for users to report problems, give feedback, challenge AI decisions, seek redress if harmed. This operationalizes the principle of contestability. And finally, regular audits by both internal teams and independent external parties are needed to ensure ongoing compliance, fairness, and ethical alignment as the system operates and evolves over time.
So it's a continuous loop of monitoring, feedback, and improvement.
Exactly. And throughout all these stages, documentation is truly the golden thread. It connects everything and enables robust accountability. Think about how it weaves through. Data sheets for data sets capture data context and biases. That informs development. Then, model cards summarize model performance and limitations, flowing from evaluation. This continuous chain provides a clear, auditable trail from concept to deployment and beyond. It prevents that diffusion of responsibility where no one knows who made which decision. It's how we move from just good intentions to demonstrable, responsible practices.
That's a great summary of the life cycle. So you might be thinking, okay, this all sounds great, principles, life cycle stages, but how do we actually do this? What are the nuts and bolts?
Yeah.
That's where the rubber meets the road. This next section is precisely about that. Specific technical methods and open source tools developers can use right now to actively detect and mitigate bias and to make their AI models more explainable. It's the practical side, moving from theory to tangible action.
Precisely. Let's start with bias detection and mitigation techniques. These strategies are typically categorized by when they're applied in the pipeline: pre-processing, modifying the data before training; in-processing, modifying the algorithm during training; or post-processing, adjusting predictions after the model is trained. Generally, the best practice is to mitigate bias as early as possible, ideally in data collection and preparation. It's much harder to fix deep-seated biases later on.
Okay, so fix it at the source if you can. What are some pre-processing techniques?
In pre-processing, we modify the data itself. Reweighing is one. It assigns different weights to samples, giving higher weights to underrepresented groups to balance their influence during training without actually duplicating data. Resampling changes the dataset's composition. This includes oversampling, duplicating minority samples; undersampling, removing majority samples; or more sophisticated methods like SMOTE, synthetic minority oversampling technique. SMOTE generates new synthetic data points for the minority class, similar to existing ones but subtly different, helping create a more diverse balance. Another technique is the disparate impact remover. This modifies feature values to try and equalize their distributions across protected groups, reducing unwanted correlations with sensitive attributes that the model might otherwise exploit.
Okay, so tweaking the data itself. What about in-processing during training?
Moving to in-processing, these techniques modify the algorithm itself while it's learning. Adversarial debiasing is a really interesting one. It trains two neural networks simultaneously: a primary model for predictions and an adversary model. The adversary tries to predict a sensitive attribute, like race, based on the primary model's internal representations. The primary model is then penalized if the adversary succeeds, forcing it to learn representations that actively discard or minimize sensitive information. It learns to be unbiased to fool the adversary.
That sounds clever. A built-in bias detector.
It is. Regularization is another common method. You add a penalty term to the model's loss function during training. This penalty discourages the model from relying too heavily on features known to be biased or that act as proxies for sensitive attributes. And fairness-aware optimization techniques use a loss function specifically designed to penalize fairness errors, not just prediction errors. An example is MindIff, which works to balance error rates between different subgroups, ensuring the model doesn't perform significantly worse for one group.
So building fairness right into the learning objective.
Okay, and finally, post-processing, after the model is built.
Finally, post-processing methods. These are applied after training, adjusting predictions without altering the model or data. Useful when you don't have access to the training data or model internals or retraining is too complex. Calibrated equalized odds is one. You adjust the prediction thresholds differently for various demographic groups. The goal is to equalize specific error rates, like false positive negatives, across those groups, even if the raw model performs differently. Reject option classification works by identifying predictions that are highly uncertain, especially near the decision boundary. For these uncertain cases, the algorithm can be set to systematically assign favorable outcomes to unprivileged groups, nudging the overall outcome towards fairness.
What's really striking about all these techniques, pre, in, post, is how they offer different levers, different points of intervention depending on where and how the bias is creeping in. It's not a one-size-fits-all solution, is it? Not at all. It's truly a comprehensive suite of tools developers need to understand and apply thoughtfully, choosing the right tool for the right problem at the right stage.
Right. In complementing bias mitigation, you mentioned explainable AI, or XAI.
Exactly. Explainable AI, XAI techniques are designed to help us interpret those decisions made by complex, often opaque, black box models.
Yeah.
LIME, local interpretable model agnostic explanations, is popular. It explains an individual prediction. How? It creates small variations, perturbations of the specific input you're interested in, then trains a simpler, interpretable model, like linear regression, locally, just around that input. This simple model approximates the complex model's behavior for that one outcome. So it answers, why was this specific customer's loan denied? It provides local transparency.
Okay, explains one decision at a time. What about SHAP?
SAP, Shapley Additive Explanations, offers a more unified, theoretically grounded approach based on cooperative game theory Shapley values. It calculates the marginal contribution of each feature to the prediction, considering all possible combinations of features. This means SAP provides both local explanations for individual predictions, like LIME, and also powerful global explanations, showing which features are most important across the entire dataset. Gives you micro and macro views of feature importance.
Sounds powerful. Are these easy to use? Any catches?
In terms of implementation, Python libraries like SHAP and LIME make them pretty accessible. However, XAI isn't a silver bullet. Our sources warn that explanations themselves can sometimes be misleading or create a false sense of security. LLM's effectiveness can depend heavily on the perturbation strategy used. SAP can be computationally expensive for very large models. So, while powerful, they require careful, critical application and interpretation.
Okay, so tools exist but need careful handling. Are there toolkits that bundle these things?
Yes, several essential open-source toolkits have emerged, making these practices more accessible. IBM AI Fairness 360, AIF 360, is comprehensive. A Python toolkit with over 30 fairness metrics and over 10 bias mitigation algorithms spanning pre, in, and post-processing. Covers a lot of ground. Microsoft FairLearn also assesses and improves fairness, emphasizing a socio-technical approach considering technical aspects alongside human societal context. Provides assessment dashboards and mitigation algorithms. Google What If tool, WIT, is very intuitive. An interactive visualization tool for probing model behavior with minimal coding. Explore performance and hypotheticals, analyze feature importance, visualize behavior across subgroups. Great for communicating fairness issues to non-technical stakeholders. And IBM AI Explainability 360, AIS 360, is a companion to AI 360, focusing on explainability. Offers a comprehensive set of algorithms for explaining both data characteristics and model decisions. Helps demystify those black boxes.
Wow, quite a few resources out there. But this deep dive into the technical tools brings us back to a fundamental reality, doesn't it? What some call the no free lunch theorem in ethical AI. The blunt truth seems to be there are no perfect solutions. There's no single method that can simultaneously maximize fairness, accuracy, and explainability without some form of compromise. Is that right?
That's absolutely correct. For example, many powerful bias mitigation techniques might actively reduce unfair outcomes, but they can also explicitly reduce a model's raw accuracy to do so. You might trade a bit of overall accuracy for much better equity across groups.
A direct trade-off.
Often, yes.
Uh,
Similarly, the models achieving the highest predictive performance complex deep neural networks are often the least interpretable. Another direct trade-off: peak performance versus transparency.
So the developer's job isn't finding the magic bullet algorithm.
No. It's about navigating this complex landscape of inherent trade-offs. It requires deep, context-specific understanding of the problem, the data, the potential impact. And crucially, it demands transparently documenting the choices made and the rationale behind them, using tools like model cards to communicate those compromises clearly.
It's about making reasoned ethical judgments and being incredibly upfront about them. Okay, now all these principles, frameworks, technical tools, they really click into place when we ground them in real-world examples. Tangible outcomes. These aren't just cautionary tales, are they? They're powerful illustrations of both the severe consequences of ethical failures and also the significant benefits when responsible AI gets implemented right. They show us what happens when we get it wrong and what's possible when we get it right.
Absolutely. Let's begin with hiring and recruitment, a classic domain showing the peril of historical data. The most cited case, for good reason, is Amazon's AI recruiting tool. Developed around 2014, meant to screen resumes, it was ultimately scrapped. Why? It was found to be inherently biased against women. The system, trained on historical resume data mostly from men in a male-dominated tech industry, inadvertently learned to penalize resumes that contained the word women's, like women's chess club captain. It even downgraded graduates of 2 all-women's colleges.
Wow, just based on historical patterns.
Exactly. A textbook example of historical bias, the big lesson. Simply removing explicit attributes like gender isn't enough. Models are incredibly adept at finding subtle proxies. It underscores the absolute necessity of thorough data audits and rigorous fairness assessments, looking for both explicit and latent biases.
Okay, a clear failure. What about finance? You mentioned duality there.
Yes. Finance and credit shows the duality of algorithmic lending, how AI can fail spectacularly, but also succeed remarkably. A significant failure case: algorithmic bias in loan applications. Numerous investigations found discriminatory patterns. A Wells Fargo algorithm assigned higher risk scores to Black and Latino applicants with similar profiles to white applicants, leading to higher denial rates. More recently, studies show LLMs recommending higher interest rates for Black applicants than white ones for identical scenarios. Shows how easily bias scales.
Troubling. But you said there's a success story, too.
Yes, a compelling success case. Upstart's Inclusive Lending. They use AI to analyze a much wider range of data points beyond just traditional FICO scores, which often disadvantage underserved groups. By including things like education, job history, they've managed to approve significantly more loans for a broader and more diverse range of borrowers, while simultaneously reporting lower default rates.
So using more data, thoughtfully expanded opportunity.
Precisely. The lesson: AI is a double-edged sword. Naive deployment with biased data can automate and scale discrimination. But thoughtful deployment with diverse, carefully chosen data can actually challenge and correct those same injustices.
Fascinating contrast. What about criminal justice? The stakes seem incredibly high there.
Arguably the highest, dealing with fundamental liberties. Here, predictions can profoundly reinforce inequity. The infamous Compass recidivism algorithm is a critical case study. Used to predict reoffending likelihood, a ProPublica investigation found it racially biased. It was nearly twice as likely to incorrectly label black defendants as future reoffenders, false positives, compared to white defendants, and conversely, more likely to mislabel white defendants who did reoffend as low-risk, false negatives.
So, biased in both directions, disadvantaging black defendants.
Correct. Another concerning case involves ShotSpotter gunshot detection tech, where a wrongful conviction was partly attributed to inaccurate and insufficient AI-generated evidence. The lessons. The ethical bar for AI is exceptionally high in criminal justice. Compass highlights the critical importance of transparency and fairness definitions. It was a proprietary black box with a flawed fairness definition inside. ShotSpotter shows the dire consequences of relying on unaudited, inaccurate AI. Both underscore the need for robust human oversight, contestability, and a healthy skepticism of AI as a false solution, masking deeper systemic issues.
Extreme caution needed there. Healthcare also feels critical.
Absolutely. Healthcare brings us to life, death, and data diversity, a significant failure case. Biased diagnostic tools. An AI dermatology tool was found up to 40% less accurate in diagnosing skin conditions for patients with darker skin tones. Why? Representation bias, trained predominantly on images of light-skinned patients, making it unreliable for many.
A direct consequence of non-diverse data. Is there a success story here too?
Yes, a powerful success case. Mayo Clinic's use of explainable AI, XAI. They integrated XAI models in radiology. These models provided diagnoses and explanations showing what features the AI focused on. This allowed radiologists to understand, validate, and ultimately trust the AI's recommendations. This led not only to higher diagnostic accuracy, but also significantly higher physician adoption of the AI. Transparency built trust and improved outcomes.
That really shows the power of explainability in practice.
It does. The lessons are stark. Data diversity is not optional. It's a fundamental prerequisite for safety and equity in healthcare AI. And AI isn't safe if it doesn't work reliably for all patient populations, and XAI is clearly a powerful tool for achieving that trust and ensuring reliable performance.
Okay, one more domain, facial recognition. What does that teach us?
Facial recognition starkly illustrates the challenge of intersectional bias. Research, especially the Gender Shades Project and follow-ups, consistently showed significant performance disparities in commercial systems. They notoriously perform best on lighter-skinned males and worst on darker-skinned females. The error rates for the latter group were sometimes orders of magnitude higher.
Orders of magnitude, that's huge.
Huge. This is a powerful illustration of intersectional bias, where harm is compounded for individuals belonging to multiple marginalized groups, for example, based on both gender and skin tone. The key lesson. Fairness audits must go beyond testing one attribute at a time. They must rigorously test performance at the intersections of sensitive attributes to uncover the most severe, often overlooked biases affecting the most vulnerable.
Looking at the combined effects, not just single factors. Okay. Across all these diverse domains, hiring, healthcare, finance, justice, a clear, maybe even chilling pattern emerges. AI failures seem rarely to be a single, isolated technical bug you can just patch. Instead, they're almost always systemic. They arise from this chain of flawed decisions, unexamined assumptions, overlooked implications throughout the whole development process.
That's exactly right. Whether it was Amazon's tool, Compass, that dermatology app, the failures weren't just faulty code. They consistently lacked proper data documentation, rigorous impact assessments early on, comprehensive fairness audits across subgroups, and meaningful stakeholder engagement. It's the same story, different context.
Which profoundly demonstrates that mitigating AI risk is not about finding and fixing a single point of failure. That approach is fundamentally flawed.
Completely. It requires building systemic resilience, embedding ethical considerations at every level, every stage.
And that resilience is achieved, fundamentally, by diligently implementing those end-to-end governance frameworks and the responsible development lifecycle practices we've spent so much time discussing today.
It seems like the only way to move from just reacting to problems to proactively building AI we can actually trust. What an expansive journey we've taken today. We started by highlighting just how pervasive AI has become and that absolutely critical, necessary shift away from the old move fast and break things ethos, moving towards a comprehensive, holistic consideration of an AI system's real impact on society. We meticulously unpacked that trustworthy AI framework built on those three crucial interdependent pillars, ensuring AI is lawful, ethical, and robust. As you, our listener, think about building or interacting with these increasingly intelligent systems, here are some actionable recommendations, some key takeaways to carry forward from our deep dive today. First, establish robust governance. As you assess or participate in organizations developing AI, look for those well-defined cross-functional ethics committees. Look for established risk management frameworks like the NIST AI RMF. These are the foundational structures for thoughtful, principled development.
Absolutely essential.
Second, adopt a responsible AI lifecycle. Really internalize this idea that ethical considerations aren't an afterthought. They must be deeply embedded into every stage, from initial envisioning right through continuous monitoring. And crucially, remember meticulous documentation, data sheets for datasets, and model cards as the golden thread of accountability linking every decision.
That documentation is key.
Third, master the technical toolkit. Get genuinely familiar with the range of bias detection and mitigation techniques in post-processing. Understand how explainability tools like LIME and S-Shade can demystify black boxes. Leverage those open-source toolkits like AI Fairness 360 or Google's What If tool. These are your practical instruments.
Know your tools.
And finally, learn from the field. Continuously study both the illuminating successes and failures from real-world AI deployments. These case studies aren't just anecdotes. They're powerful, tangible evidence for why a comprehensive end-to-end approach is not just preferable, but absolutely critical.
Those lessons are invaluable. And if we connect all this to the bigger picture, the future of ethical AI is clearly moving from mitigation to ethics by design. This isn't just about patching problems after they emerge. It's about proactively embedding ethical values and safety principles into the very architecture and purpose of an AI system from its inception. The fundamental question shifts. It goes from how can we retroactively make this biased system fairer to how can we design a system that is inherently fair, inherently robust, inherently beneficial right from the start. This proactive, human-centric approach is ultimately more effective, more sustainable, and truly scalable.
Building it right from the beginning, not fixing it later.
Exactly. And that brings us back to the responsibility of the developer, which is truly enduring and profoundly impactful. As the architects of an increasingly automated world, AI developers, data scientists, engineers, they hold a unique and weighty societal responsibility. The systems they build aren't neutral. They encode values, they make judgments, and they ultimately distribute opportunities across society. So the ultimate goal for all of us, then, isn't just to build what is technically possible. It is, much more importantly, to build what is ethically sound, demonstrably fair, and truly beneficial for all of humanity. This raises a final important question for you, our listener. As AI continues to evolve, integrating even further into every facet of our lives, how will you contribute to ensuring its ethical future? Whether you're a developer shaping these systems, a consumer using them, or simply an informed citizen engaging with this transformative technology, the choices we all make now will absolutely define the AI systems of tomorrow.